Okay, so this is a quick video, an introduction to the flow around the bend apparatus. So we're looking at airflow as it flows around the bend. The apparatus, I'll just do a quick run through from start to finish. So what we have here is a centrifugal blower with an electronic speed controller. So you can set the speed of the fans in RPM to whatever you want. What that fan is connected to then is this chamber here called a plenum chamber. Essentially, it's a box, a pressurized box. So the air from the centrifugal blower is going into the box here, pressurizing the chamber. There's a set of baffles within that then that'll kind of reduce some of the turbulence in the air, so that in theory you should get a laminar flow air coming out the opposite end of the chamber. Okay, so on the opposite end of the chamber we've got a couple of different modules. One of the modules is this flow around the bend apparatus. So looking down in plan view on that, what we have is a right angle bend coming out from the one end of the plenum chamber. Now actually what I'll do is I'll just pause for a second. We'll go and I'll have a look at a plenum chamber just to see what's in it. Okay, so here's another example of a plenum chamber here. So this would be where the air goes in from the centrifugal blower, and it hits a plate there, it gets separated out, and then you've got a series of baffles here, one after the other, before the air would eventually come out then at the front of the chamber. Okay. Now you have a pressure tapping at the top that you can measure what the pressure of the air inside the chamber is, and use that for comparison, depending on the experiment you're looking at. Right, I'll go back over to the main experiment now. Okay, so back with the flow around the bend apparatus. So what you have at the exit from the plenum chamber here, we've mounted onto that, kind of bolted on here, this flow around the bend investigation apparatus. There's a series of different pressure tappings. We have a 90-degree bend coming out of there, a series of different pressure tappings. So one example here, we've got 4 pressure tappings radially across the bend, and I looked at that in the video on the manometer, using the manometer to measure those pressures. So you would literally take those air lines and connect them up to a manometer to measure the difference in pressure compared to atmospheric pressure. Okay, so there's 4 radially across the bend. You also then, on the inner section of the bend, there's 1 pressure tapping here separate, just at the exit from the plenum chamber. Okay, so this is kind of at the exit from the plenum chamber itself, rather than on the radius of the bend. So that's this one here. Okay. Then, so I have that one hooked up to the manometer at the moment. Also, then we have 10 pressure tappings along the inside circumference of the bend, or along the inside curvature of the bend. There's 10 pressure tappings, and you can hook those up to the manometer. Now currently at the moment I have it connected up to, there's 10 pressure tappings on the outside of the bend as well, so numbered kind of from 1 being closest to the plenum chamber, and then 2, 3, 4, all the way up to 10 at the very outlet from the apparatus here. So the air is going to come out here to atmospheric pressure. Okay, so those 10 are connected up to the manometer here. So what I have is connected to the top of the manometer here. I have 1 connected to the pressure in the plenum chamber, and you'll see that referred to in the manual as the plenum pressure. Right, so that's the plenum pressure here. I have 1 here that's just open to atmospheric pressure, so I can look at the difference in height in the columns. This one here is connected to the outlet from the plenum chamber, so that's just this one here as it comes out from the chamber. The next one is open to atmospheric pressure again, and then I have 10 pressure lines numbered kind of from 1 being closest to the exit from the chamber all the way around to 10 at the very exit from the apparatus where it goes out to atmosphere. Okay, so I'll pause it there and I'll start the fans up, and I'm going to run it at a particular speed, so let's say around about 2000 RPM. Okay, so at the moment all of those pressures are just they're at the same height as the level of the reservoir of the manometer. Okay, so I've set the electronic speed controller of the centrifugal fan here, centrifugal blower. I've set that to 2100 RPM just for an example's sake. So that now is pressurizing the chamber here, and we can measure the pressure that chamber is at. And the air then is exiting the chamber. It's flowing around the bend, and it's flowing out the outlet here. Not sure whether you can hear that or not, but it's coming out there, and I can measure those pressures then using the manometer. And you'll see actually straight away looking at the manometer how you get a visual representation of the distribution of pressures around that outer surface of the bend. Okay, so my pressures again are the plenum pressure. This one is opened atmosphere. This is the exit from the plenum chamber. This one is opened atmosphere, and then I have my 10 readings along the outer surface of the bend. Okay, so what I'll do is I'll post readings. They may not be these exact readings here, but what I'll do is I'll post values for heights in millimeters. Now, in each case, what you'll need to do is to work out what's the difference between the value in a column versus atmospheric. So this one here is opened atmosphere, this one is the plenum chamber. So you need that height difference in meters, and then rho by G by H will give you that pressure in pascals. Okay, so that's opened atmosphere. That's the exit from the plenum chamber. You'll see is a slight positive pressure. The pressure in the plenum chamber is a large positive pressure, so you have a big height of liquid there, or height difference there. This is the plenum chamber. The plenum exit pressure is a slight positive pressure. This then is open to atmosphere, and then from here on, that's the 10 readings along the outer surface of the bend. And you'll see that, so this one here is atmospheric pressure. I'll come out a little bit. This one here is at atmospheric pressure. This is a slight positive pressure, and the pressure is getting larger and larger and larger and larger. Kind of this would be the outside of the radius of the bend, and then the pressure is coming back up towards, or it's coming back towards atmospheric pressure, let's say. So this is atmospheric pressure. This one here is open to atmosphere. Okay. So this one here would be a very, very slight vacuum just at the exit from the apparatus back to zero. So so this would be number 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you see kind of a distribution of pressures as you go along. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you'd have a similar idea then. What I'll do is I'll post 10 readings for the 10 on the inside of the bend, but what you'll probably see in this case is you're going to see a slight vacuum as you go along the inside of the bend, and a slight positive pressure on the outside of the bend. And you can plot graphs of those pressure values at those locations. And you can also work out coefficients of pressure if you compare them to the exit from the chamber. Okay, and there are formulas for all of those in the lab manual for this experiment. Okay, I'll finish up the video at that, and I'll post further videos then of the different apparatuses. So the other apparatus that you can connect to this plenum chamber is the one looking at the Venturi effect, and I'll post a separate video on that.